As we get rolling today with, I think this is our third iteration of the Algebra 2 F word, of many more. We're going to solve today by factoring. Now, what we've done so far, we've factored like these, okay? I can't stress this enough. I'm going to write it again, okay? The first question on every single factoring problem you ever do is there anything in common I can pull out? Sometimes it'll make it easier. Sometimes you got to do it or you're just getting flat and get the wrong answer. So, for instance, on number 1, and again, the anything can be a constant, a variable, both. Here, I can divide both of those by 5. Now, it doesn't mean the problem just became x squared minus 4. The 5's still there, it's just outside. And so if I divide that 5 into each of these, I get here. But I'm not done. Sometimes I might be done. We might see a little one later on that we see that. But whenever you're in two terms, usually either something's in common or and in this case, it's a difference of squares. At this point, we shouldn't have to be depending on that chart to get our squares up to about 12. I mean, if you still have it, I don't care, but this should be ringing out right away. Okay, I square x to get x squared, I square 2 to get 4, and by this point, with the amount of times that it's been written on quizzes and homeworks and everywhere else, you've got to know your difference of squares. If you don't, I would suggest going to my YouTube page and type in factoring. You'll have all sorts of things looking at you. A plus B, A minus B. Not x minus 2 squared. Not just x minus 2 once. Okay? Difference of squares. First plus second, first minus second. You're done. That one, we've got to know the form or we're not going to get it right. Number 2, you have options. Number 2, some of you may look at number 2 and go, okay, this is a normal factoring one. That's the multiply, that's the add number. And you're like, that's cool. So you'd be like, all right. Everything's plus, okay. What multiplies to 9 and adds to 6? Same two numbers. 3 and 3. Or just write it this way. If you happen to notice, though, back at the beginning, that these were both perfect squares, P and 3, you could P3, and then you just take the middle term with it. Okay? Both get you to the right place. So I don't care which one you do, but sometimes if these numbers get big, it might be easier if you just know the squares. So again, the more tools, the better off we're going to be. Oh, let's see. What do we have in common on number 3? 2a. Divide 2 into both, divide a into both. So 2 divided by 2, subtract your exponents, so I need one more a. 8 divided by 2 is 4. I've already got one a, I do not need another one. How do I know if I need to do something more or not? If it's squared, you need to check, because it's still a quadratic. If it's not a quadratic anymore, you know you're done. There's no further you can go. So if you ever see squared still, look, you might have something to do still. Ooh. Gosh, I don't even know where to go with some of you on this. There's like 3 options. Easiest option, I notice my first and last terms are both perfect squares. So I'm like, all right. And whatever the term is in the middle, my sign, that's what I put. That's the fastest. Now, could you still do guess and check? Could you still do slide and divide on this? Absolutely. You absolutely could look at these and go, all right, so I got 4 and 1, or 2 and 2, or 3 and 9 and 1. And I just am messing around with each pair to see, hey, how can I get to this 12? 12 and 3, no. 12 and 3, no. 36 and 1, heck no. Ooh, wait, 6 and 6. 2 times 3 is 6, 2 times 3 is 6. So you'd be like, So you'd be like 2x, 2x, 3, 3. They multiply to a positive, which means they're the same sign, that one. Got the same thing. By sliding dividers, all I will say to you is, if you're going to go that route, and you could, but I keep seeing this when I see people do it on practice in the quiz, when you slide your 4 down, and then you factor what's left, you can't stop here. You've still got to do the dividing part, and, like, dang, you've got to make sure your fraction's reduced. Because if it's not, you're not going to get the right answer either. And at this point, you should be starting to get an idea of how you want to attack these problems. Slide, divide, guess, and check, know the form. If you're still in mode, it's because you haven't been practicing them. I mean, that's just as honest as I can be. Because at this point, we should be able to just kind of look and go, okay, I got to attack it this way. I got to go after it this way. And if not, just make sure you're doing more of them now. Okay? The only difference moving ahead is going to be now we're using this zero product property, which basically means once I'm factored, I can set each piece of my factoring equal to 0 and actually get answers, get x equals in a number, which is nice. So, this is where we're going to kind of bop around and do some of these different ones, but I'm not going to go crazy with a lot of the basic ones. So, like, for instance, here, okay, we'll do one basic. One basic is fair. And every time you have to solve, it's going to say solve, and there's going to be an equals sign. Otherwise, you are not solving. Just keep that in mind. Okay. Multiply, add. Multiplies to a negative. We know it's one of each sign. When it multiplies to a negative, we also know to look at the middle term, again, to remind yourself, hey, bless you, my sum has to be positive. Multiplies to 18, gets me to 3, one of each sign. 6 and 3. Positive 6, negative 3, gets me to 3. Here's the only difference. Now we have one additional step. We take each of the quantities that has an x and we set them equal to 0. Notice the answer wasn't 6 and negative 3. It was the opposite of those signs. You're still solving. You have to do an opposite to get those alone. So be careful. Also, your equations before you start factoring need, oops, let me move that down a little, need to start with equals 0. If they don't, you need to fix that first. So here, I need to minus the 3r over. I need to add the 5 over. Okay, got to have that equals 0 first. Then we start busting out every factoring tool that we have, including anything in common, 2. Now, could I have solved it without taking out the 2? Yeah, but man, this is easier. Because now it's just regular old r squared. And even better yet, if I'm paying attention, I notice that my first and last terms are perfect squares. Now, if you do it one of the other ways, it's not wrong. So here, if I notice this, okay, that 5's that squared is on here. If you did r minus 5, r minus 5, and you were just using regular factoring, that's fine. You're still in a good spot. So this time, I only had one unique set of parentheses to solve, because this is what's called a double root. This is the one time that you're only going to get one answer. So just to kind of let you pictorially see why that's happening, I'm just going to put it in here quick to let you see. Because what happens is, you notice how the parabola comes down, it just kisses the axis and goes back up. It doesn't come below it. That value right there at x equals 5 is the only answer, but we call it a double root. It's like a double answer because everything's got two answers. That's the only time. With these other ones, if you graphed them, you would physically see them going through the axis at each of those values, is what we're trying to do. The rest of the ones we're going to do, I'm just going to give you some hints on some things in case you get stuck in some areas. Like here, negative a value, awful, hate that. So I'm going to fix it. If I get a negative a value, you can do a few things. I'm just going to divide through here, and again, in the notes, I'm going to write it. I normally wouldn't. I'm going to divide everything by negative 1, because I'm doing the same thing to both sides. That's going to be easier to work with. But I still got to take my time to do all the other stuff that I normally would do. I still got to find my common factor. And once I get that out, could I get to the right answer if I didn't take it out? Maybe. I won't guarantee it, though. And here we go again, back to normal regular factoring. I'm not even having to do guess and check or anything like that because I was smart and I took out that common factor. Now I'm just doing the regular old what multiplies to this and adds to this thing. It pays to take that common factor out. One of each sign. Bigger number is going to be negative. They're one apart. They multiply to 30. But now, what gets set equal to 0 and what doesn't? That 2 does not have a variable. You can't set 2 equal to 0. That's not a thing. So why do we have it there? Because we're still factoring. So that does not get set equal to 0. These do, though. And I can get to my two solutions. Okay, so that's a little twist. It's not a huge, it's a little one. But it's one that's there nonetheless. And so, as we start to finish some of these off, I'm just kind of seeing where I want to go. Definitely there. Definitely here. Oh, mercy, definitely here. And here. Okay, that should get us in a good spot. Difference of squares. I squared 2 to get 4 and x to get x squared. I square 5 to get 25. And again, we've got to know the form on this one. First plus second, first minus second. That's why we write this stuff down, to kind of help remind us. Bless you. And then again, we're just doing Algebra 1 things. We're just making sure as we do this, we don't screw up signs. So usually, one question I've gotten in the past is, well, why do we have to do this? Don't we have a calculator? Couldn't we just trap the roots and not worry about it? Technically, yes. But what if you get into a situation sometime on a standardized test, or if you're doing something with the ASVAB, if some of you are pondering military and stuff, they have sections you're not going to have, like, calculator availability. So what are you going to do? Uh-oh. This is why we get more tools in the toolbox. So if one tool gets restricted, we still have other ones to be able to deal with and make do. Okay, last couple. Up here. Again, we got to have equals 0. So 24x, you get to come on over. Oops, if I write it that way, 24x. There we go. Take out what's in common. Get the biggest stuff. So 8 will go into both. Don't be content with 4. They both have x. And just take your time on this part. I already got the 8. I got 1x. I need 2. So let me get one more. Negative 24 divided by 8 is negative 3. I already got the 1x. But now here's the difference between number 7 and number 10. On number 7, our common term didn't have an x with it. We couldn't set it equal to 0. On number 10, it does have an x. If it has an x, it needs to be set equal to 0. And you can divide 0 by 8 and still get an answer. It's not undefined. Your calculator will tell you the same thing. And I get my 2 solutions. And so finally, to wrap up the top part, here, nothing in common for all 3 terms. You're like, okay. So now your choice comes back to, am I going to guess and check? At least I know this is 3 and 1. I do know one thing, though. Since my multiply number is positive and this is negative, I know these will both be negative, so I can do that part. So I go looking to see, how do I get to 14? So if I go guess and check, I'm like, well, 5 and 3, that's 15 and 3, no. 9 and 5, ooh. So 9 and 5 would get me there. So, okay. So we got 5x and 3x. And again, I want inners together and outers. So 3's go together. 5 and 1 goes together. Negative 5. Negative 9, negative 14. Negative 3 times negative 1, positive 3, yay. Sliding dividers, I'm not going to forget about you. Give me just a sec here. Add my 3. Divide by 5. Add my 1. Divide by 3. Slide and dividers. Couple of quick reminders. Then we'll get on to the last little piece here. Multiply that down. We're in a regular multiply and add problem. We're not in guess and check mode. I mean, we kind of are. Multiplies to a positive, they're going to be the same sign. That one. Multiplies to 45 and adds to 14. 9 and 5. Don't set those equal to 0. Don't do it. Don't do it. Got to do the divide part if we're going to do this. And again, make sure they're reduced completely. Because if they're not, you're going to run into trouble. Now, some of you are going to notice something here in a minute. And I'm going to warn you, when you want to do this, I'm still going to give you a heads up not to. Set those equal to 0, I get the same answers. Here's what my slide dividers normally tell me. They're like, wait a minute. If I reduce my fractions completely hard, it's like the answers. Why can't I set these equal to 0? Because if I do, it's going to be 3/5 and it's going to be 1/3. I'm getting the right answers. Yay. If you do that, if we're on a quiz and you stop factoring there, you will get credit for the right answers. I'm not going to tell you you won't. But I'm going to take a point away because that's not factored correctly. This does not equal this. Okay? You still need to factor. Now, if you want to look at that at the end and say, oh, my answers are just that, just switch the signs. Great. But you've got to factor correctly still. So I'm just trying to plant a couple of seeds to make sure we don't get ourselves in trouble. We don't want trouble. Trouble's bad. Bad, bad, bad. Okay, Hardy, take a breath. Issues so far that we're running into, because I tend to get happy and roll, and then people are like, what the heck? Not yet, okay. Maybe in a bit, we'll see. We chatted about these before. Write a quadratic in standard form with the given zeros. We're going to work backwards. So these are the ones where we took the answer and we put it with x and changed the sign. Positive 2 becomes negative. Positive 3 becomes negative. And now I'm just going to FOIL this out and I'll have the quadratic back. So change signs up there. Now we're going to FOIL. And we're going to combine those like terms in the middle. My slide and dividers are going to have an advantage on the second one we're going to do. Ooh, fractions. Yay. We're going to do it the same way. We're changing the signs on both. Now we're going into slide and divide mode, which is pop that denominator back to the front. FOIL that stinker out. So we got positive 8 and negative 15 would be negative 7x. So all you're having to do to write the quadratic, flip the signs of both answers when you put them in your quantities, your parentheses, then FOIL them out. So one application, and then one more intro with something we haven't seen in a while, and I think we're going to be all right. How do you find the area of a rectangle? This is not a trick question. Length times width. So length times width equals area. You're like, all right. Find the dimensions. Oh, man. Distribute. Hopefully we start to see where we're heading here. You're like, oh yeah, it's got to be equal to 0. 36 has got to come over. And now we're going to factor and we're going to get solutions. But this is one of those times that we have to be cautious of not just scribbling down whatever answer we see, which you're about to see. Because, let's see. 1 positive, 1 negative, multiplied to 36, add to 9, 12, and 3. And I set those equal to 0. So here's the first thing. The two solutions you get are not what the dimensions are, okay? These x's up here, we're going to plug in our x to get the dimensions. You're like, but I have two answers, but we got to use common sense here. I don't think the side of a rectangle is going to be negative 3. Okay, that one doesn't work, so we're not going to use it. 12, though, works. So 12 minus 9 is one of my sides. 12 is the other. So 3 by 12, or 12 by 3. 3 times 12, 36. That works. But again, if this is a quiz, I want to see the work done, not just you playing guess and check with numbers until you find something that works. I always like to put that out there because people like to try that. Last thing. We're going to do one simple, one tricky, and then I'm out of your hair. Okay, 19 and 21, we're done. This was a chunky section. It's like Friday was short, and this one's chunky. Factor by grouping. Normally, what you're going to be able to do is you're going to be able to just pair these off in the order that they're in. Normally, we're going to take out the greatest common factor for each one. So you got to make sure you get all of it. So here I got a 3, and I can get an x. What have I got left? Let's see. 9 divided by 3. So we got 3. I need another x. Here I got the 3. I got the x. I need the y. Here's the key. When I do it for the red one, my set of parentheses better be the same. If it's not, something went wrong somewhere. Or I need to do something else. So I look. I'm like, all right, I can get a 2 out. And I can't take out anything else because they got different variables. All right, let's see what we got. 6 divided by 2 is 3x. Negative 2 divided by positive 2 is negative 1y. That's what I'm looking for. I need this. But I'm not quite done. To get my answer, I take the leftovers. I take my greatest common factors. I put them together in one set of parentheses. So the outside stuff goes together. And then your matching quantity goes together. Not squared, just one. And it doesn't say equals 0. So you're not doing, no solving, don't even try. Okay, we wouldn't be able to anyway, it's 2 variables. And you're done. 9 times out of 10, it's going to look like this. If you factor them right in the order they're in, you're going to be great. There's always got to be that one stinker, though. All right, Post-it note time. I'm doing this one in order on the Post-it, so you know what's about to happen to me. So I get to here, and I'm like, all right, okay, I can take a 4 out of there. So 3c squared x plus d squared y. Yuck. There's literally nothing I can take out of the second one. Okay, that was bad. That did not work. What's happening here? Sometimes we have to regroup the order they're in to make it go better for us. So like, for instance, to me here, when I look at this, I notice this term and this term has c squared, this term and this term has d squared. That's just me. That's where I'm going to pair them. So I'm just going to rewrite these. You could actually do this a couple different ways and be okay. Just make sure when you do this that whatever signs are with each term, you take them. Now let's see if we have a little better luck with the common factors this time. So here I can get 4, and they both have c squared. So let's see. 3, I've already got the c squared. I need the x. Here, negative 16 divided by 4 is negative 4. I've already got the c squared. Y. Feeling a little better. Okay, no number in common, just the d squared. So I'm like, all right, 4y minus 3x. Okay. Oh boy. Let's see here. For my parentheses, the same. Close, but no. The signs are backwards, okay? So there's an easy fix for this. We do not need to start over. Don't get the erasers out. If I change the sign on what I pulled out, that changes the signs on both of these. It might not look the same, but I look again, negative 4y, positive 3x. These are the same thing. So now, I told you this one was unusual. Now, proud of the work if you get to here. Great. You're like, uh-oh. But I still see squared stuff. I'm like, wait a minute. That's a difference of squares. What the heck? You're like, Hardy, you're not doing this to us on something important, are you? I'm normally not that bad. I do slip every once in a while. Like I said, if you were doing a homework question and you got to here, that's like great. This would be the littlest thing of all time for us to mess with going here. But this is where we're getting to with the factoring now. There's a lot of options you have. But if you practice them, you're going to look at me like, yes, it's no big deal. Okay? And kind of work it. So how does this digital thing work? Some of you, especially if in the past you've had Mrs. Adams for anything, you know how these go. I have not done this for a while, but I was playing with it some over the weekend to make sure I could give good instruction on some of the details that can get a little crazy with it. If it gets crazy enough for some of you and you want a paper copy, I will find you a paper copy somehow, or I'll make one. But here's what I want to do now. I just want to show you some stuff because there's a lot of ways this is cool. You're going to get immediate feedback from this. So if you go to Classroom at some point, right at the top here, there's going to be this Google Sheet. So I'm going to go ahead and I'm going to pull this up. When you pull this up, okay, this is the original copy. Please, I beg of you, and I wrote this on Classroom as well. First thing to do, please, 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 please make a copy. And then just put like, and you can take out student, and I don't know, just put in whatever you're putting in. Okay? Because that way now, at least I don't have to worry about you giving all the answers to everybody. That wouldn't be cool. So you get in here, and let's say, for instance, you're looking at this first one. You're like, okay, I got a common factor. I can take out a 5. Take out an x. Okay, that's cool. So what's left? Oh, let's see. Parentheses. 7. I still need an x. 15 divided by 5 is 3. You have to put the equals 0 on the factor part. If you don't, I'll show you what happens. Okay. If it goes pink, that's not good. Something's not right. Equals 0? Yay! Okay. And I'm set. And for your solutions, you do not have to put x equals. You just set each part equal to 0. You put the answer, put a comma. You do the next part somewhere, side work, your brain, whatever it is. Put in the answer, you're done. Okay? That's not rough, all right? Not too rough, even though I might come back to number 2 in a minute. Make sure that you're in equals 0 mode before you start trying to complete these. Some of them you're going to have to play around a little bit. Because all I'm going to see is your factored answers at the end and stuff. So the one I did want to make sure that we did together besides that was down here at number 11. Because we got a new interesting little piece to this. So I'm going to do this. How do I want to do this? Let's do this. For those of you later watching, sorry, you're going to have to put it on paper because I'm doing this on the front board instead of going crazy with my screens. So we got a lot in common this time. So we're going to have to kind of play this a bit. So let's see. I got a 9 in common. I got a y squared in common. So 2, I still need x squared. Did I just take 9 and I can't take 9? Oh, already, for the love, it's 6. See, it's good that I didn't put it on there. I'd have had to go backtrack on that some. Got the y squared, 11x, 6. Okay. That's what I want to put in here. Exponents can be interesting when you're messing with these, unless you're real good with your shortcuts. I am not terrific with all of my shortcuts. So here's what I do. So here, I want to get to y squared. If you don't want to go back and forth, here was what just seemed to work. I know my answer's wrong, goofy people. I like to highlight the squared, do a Control-C, and then get back over here and Control-V. And no! You guys are like, this is funny, Hardy. This is not funny. There is nothing funny about this. There we go. See. That's better. And Control-V will paste. I'm a copy and paste guy. And then I can go ahead and I can type the rest of this in. So again, now that I've set it up, I just hit Control-V anytime I want the exponent to show up. And otherwise, it kind of just does it on its own, which is nice. So now when it says factor completely, now I've got to do my factoring in here. And again, whether I'm doing that to the side or whatever I'm doing, I'm not going to need the exponent anymore. Hallelujah. Now, some of you may just do your guessing and checking in here. It's a legitimate option. I'm just saying it may not. Oops, hang on, it's minus. 9 and 2, that's going to work. Immediate check. And then we got what? 2/3 and 3. Okay. So if you want to, when you're doing these, you're like, Hardy, I don't want to play this game. I just want to do the problem. So I'm just going to write the odds, and I'm going to write them on a piece of paper, and I'm going to do them. That's fine. I can get a paper key for this that you can check as you go if you don't want to have the immediate play it this way. But if you're going to do it digitally, just share it with me at the end, and that way I can look and make sure that you got it done. That's fine. If you haven't in a while, just press on share and include me. It might include me already since I'm the author. So that or paper, I'm fine with either, but do practice. Don't let the technology scare you away if you don't want to do it that way. I beg of you. So, but like I said, if you need the key, let me know. We'll get you set on that front, and we will not.